Yo, 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 yo. Here we go. Topic 7. So we are going to add and subtract polynomials. So some of you might say, I don't know what a polynomial is. Well, you're going to learn right now. So first, a lot of key terms right here, but again, or not again, but this is the bulk of the key terms almost for the whole topic. So there's not a lot after this. But we do need to know what a monomial is. We do need to know what a polynomial is. We do need to know what standard form is and the degree of each. So let's get those down. I will explain this as we get further along. Oh, realized I had a typo here and I caught it. So bam, there you go. I will explain this as we get going and move forward. Okay, so I think that'll kind of help to look at some examples here. So get those down and we'll look at some examples. So basically, what we're going to have to do is we're going to have to name any polynomial based on its agreed in the number of terms. So a polynomial is something that looks like this. A polynomial is when we are adding and subtracting multiple terms, okay, that are not necessarily like terms. Like this is a simplified polynomial. Okay, so I'm adding or subtracting 4 or more terms that are different terms. Now these terms can have exponents. They don't have to have exponents, but they can have exponents. They can have different exponents. They can have the same exponent, but it's multiplying or it's adding and subtracting 4 or more terms is considered a polynomial. Now, taking that back a step, we'll look at monomials. A monomial is just one single term that is, it can be being multiplied by different things. It could be have exponents. It could have multiple exponents, but as long as there's no adding or subtracting involved, it's just considered one term, which is a monomial. So 4x is a monomial. Another example of a monomial would be this guy right here. This is negative 2xy squared. So again, 3 things are being multiplied here. I'm multiplying negative 2 by x by y squared, and I also have an exponent. But this is still a monomial because it's one single term. There's no adding or subtracting anywhere. Okay. Now, we name these based on the degree of the polynomial or the monomial. So the degree of this monomial is when I add the exponents for each of the terms. Okay, so I'm adding the exponents for each of the terms. And a better way to say that is I'm adding the exponents for not each of the terms, because this is all considered one term, but for each of the variables. I apologize. So it should be for each of the variables. So I'm adding the exponents for x and y for this monomial to figure out what the degree is. Well, there is no exponent for x, but really there is a 1 there. Okay, so because there's a 1 there, we don't need to write the power of 1 because it is just x. However, there is a power of 1, so the degree of this particular monomial is 3, because 1 plus 2 is 3. So, because the degree is 3 here, the degree of the monomial is 3, it is a monomial, so this would be a cubic monomial. And then this chart is what you can use for this. Okay, I figured out what degree it is, so if it's a degree of 0, that's just a constant, like we've learned that before. If it has a degree of 1, like 4x, that's linear, which we've also gone over. But now if it has a degree of 2, when the highest is just the power of 2, that's called quadratic. Okay, we're going to get quadratic is what we're really going to focus on this whole unit, and the next unit as well. Then after it being quadratic, we have cubic when it's to the degree of 3, and then anything after that is 4th degree, 5th degree, 6th degree, so on, so on, and so on. Okay, so the special names are constant, linear, quadratic, cubic, and then after that it's just a 4th degree, 5th degree, 6th degree. And then based on how many terms they are, so we have a single term is monomial, anything with 2 terms is considered a binomial, anything with 3 terms is a trinomial, and then anything with 4 or more terms is a polynomial. So this would be a cubic monomial. So this one right here, if I wanted to name it, I have to figure out what the degree is. So this is 1 plus 1 is 2, so this is quadratic. And there's 1, 2, 3 terms, so it's a quadratic trinomial. So to name it, first we just have to determine what is the degree. And then after we figure out the degree, we need to figure out how many terms are there. Now the degree is based on the highest degree. So this one, the highest degree is 2 here. This one's only 1, and this one's only 1. So because the highest degree is 2, we just call it a quadratic. So we choose the monomial with the largest degree, And that's what we go by when we name it. Okay, cool. So now, if I were to look at this, we were going to write it in standard form, and we'll also name this one as well. So standard form of any polynomial is we go in descending order from highest degree to lowest degree. Okay, so this is like a degree of 0. This one would be 1, 2, 3, 4. So we rewrite it in where the highest degree is listed first, and then we go backwards. So, and that's just moving things around. So if I wanted to rewrite this in standard form, I'm going to put the positive 6x to the 4th power first, and then I'll go down. Well, next is to the 3rd power, and next I got negative 3x squared. Next I got positive 7x. I don't need to write to the 1st power, and then finally we always have our constant last. This is in standard form. Whenever we work with polynomials, we always write our final answers in standard form. They have to be in standard form. If they're not, they would be considered incorrect. Now if I were to name this, I look at the highest degree. Well, the highest degree is 4, so I always have to look at the one on the far left if it's in standard form. So this is a 4th degree, because we don't have special names once we get to 4. And it's a polynomial because I have 1, 2, 3, I have more than 3 terms. So this is a 4th degree polynomial. Okay, so go ahead and write these ones in standard form, and go ahead and name them as well. So write them in standard form, and I want you to name them. So pause it, write them in standard form, name them. Okay, so this first one, you'd have negative 3x to the 3rd power plus 6x squared, and that'd be positive 7. This is in descending order. So let's see, this one, the highest degree is 3, so this is cubic, and there's 3 terms, so it's a cubic trinomial. This one over here, I got negative 8y squared plus 2y minus 3. Highest degree is 2, so this is quadratic. I know it's kind of confusing when quadratic is with 2, because normally we think of quad as 4, but quadratic is when the highest degree is 2. So this is a quadratic trinomial. And again, this is something I will be dealing with a lot in this unit. Okay, last thing we're going to talk about is we have to simplify polynomials by adding and subtracting them and combining like terms. So when we talk about like terms in a polynomial have the same exponents. Okay, so I cannot combine 4x with 3x squared because of the square, and then this is a power of 1. They have different exponents, so I can't combine them. But I can combine values with the same power. So I can combine 2x and 4x as if they're like terms. I can also combine 3x squared and x squared. And really when we combine them, we're just adding the coefficients. So like 3x squared plus x squared would make, that's like a 1x squared. That's going to give me 4x squared. 4x and 2x make 6x, and then we have this plus 5 on the end not being combined with anything. So if I were to simplify this polynomial, this would be my simplified answer. I wrote it in standard form, and I'm done. And just for naming purposes to get the practice, this would be a quadratic, highest power is 2, trinomial, 3 terms. So when we simplify, just combine like terms. Now, you're going to have to add and subtract different polynomials, and so when we do that, it's really just the same thing as combining like terms. Just one thing we got to be careful of is we're subtracting these. So because we're subtracting this, we still have to follow the rules where if there's a negative in front of a bunch of stuff in parentheses, we do have to subtract all of those. So this is 6x squared plus 3x minus 2 minus 3x squared minus 5x plus 8. I swapped all the terms because I'm subtracting everything on the inside, so I distributed that negative. So this would be combining like terms horizontally. So now I can combine my like term, I can combine my x squares. So 6x squared negative 3x squared makes 3x squared. Positive 3x, negative 5x makes negative 2x. And then negative 2 positive 8 makes positive 6. Okay, one good thing when you have a lot of terms like this, maybe you want to cross them off once you combine them so you know that you've worked with it. So here's my final answer. Another way I could do this, you could line it up vertically as well. Some people like to do this. So I could have done 6x squared plus 3x minus 2. And then this is going to be, I'm going to add up negative 3x squared, negative 5x, positive 8. Now, notice how I said I'm going to add these together, because once I distribute this, I'm really just combining these, right? So I would still recommend distributing that negative first. I mean, you don't really have to, but so if you didn't want to, you could also do it like this, right? Subtract. I can put my signs back to what they were, and go positive and negative, and I can just do the subtraction. I can do 6 minus 3, that's 3x squared. 3 minus 5 is negative 2x. Negative 2 minus negative 8, this is where it gets a little tricky, because negative 2 minus negative 8 is positive 6, but this is where not distributing that negative can throw people off. So if you distribute the negative, it just makes it a little bit easier, because then you're just combining. But you can do it vertically like this, where you just line up your like terms. And there you have it. Okay, so here's what we're going to do. I want you to find r minus q. So we're taking r, subtracting q from it. And you can line them up vertically like we just did. And then you can do p minus r and try doing that maybe horizontally. Figure out which method you like more. So pause it, try it, and see how it goes. Okay, so I set them up where I have vertically and horizontally. Here is my p minus r, here's r minus q. So again, what I'm going to do right away is I am going to make this positive, and I'm going to distribute that negative by changing all of these signs. So these all became positive, and then the first one became negative. That just makes, to me, it feels a lot easier when I combine 9 with negative 7. I know I have 2x cubed. This is going to give me negative 6x squared, positive x, or positive 1x, and then positive 8. So I have a 4th degree cubic polynomial. Now over here, I'm going to distribute that negative to everything inside, and then I'm actually going to rewrite the whole thing, because this just makes it a little bit easier for me to visually see what's going on. So I have negative 9x cubed. That's going to be positive 8x squared, positive 8x, and then that's going to be negative 2. So I just distributed that negative for that subtraction, and then now I can start combining my like terms. Let's combine my cubes first. So I got negative 3, negative 9, that makes negative 12x cubed. I'm going to cross those off. Squared, negative 9x squared, positive 8x squared, so that's going to give me negative x squared. Those are gone. Negative 6x, positive 8x is positive 2x. Those are gone. Negative 9, negative 2 is negative 11. And I'm done. Finally, you'll have to do word problems. Okay, so it's gonna, what we're doing here is we're combining these areas. So we have 4 small panels, 33 medium panels, and 32 large panels. It actually gives me the area of all of the small panels combined. So I don't know why we're giving this information, because this is including all 4 of the small panels. This is including all 33 of the medium panels, and this is including all 32 of the large panels, and we know that also because of the 32, the 4, and the 33. So what I'm going to do is, if I want to find the total area of the farmers panels that we have out here, is I'm just going to add all 3 of these values together. So I have 32x squared plus 384x. I have 4x squared plus 24x. And then we have 33x squared plus 272x. And really, I'm just adding all of these together. So this is where we got to do a little bit of addition here, and combine my like terms, but I have them lined up, so it makes it pretty easy. 32 plus 4 plus 33. Well, that's 36 plus 33. Let's see here. So that's going to give me 69x squared. Okay, 4 plus 4 is 8 plus 2, so that's going to give me 10. I'll actually borrow here. So 9, 11, 18, and then 5, 7, plus 1 is 8. Oh, and that's got an X on it. So there's the total area of all the combined panels. Okay, that is it. So nothing else. One big thing to remember is, and this is probably the biggest mistake, is if I had something like this, this equals cubic or degree of 3. because people forget that all the time, that this x still counts. A lot of people would call this one quadratic, but it is cubic because of the x with the 1. Okay, so go ahead and simplify both of these. That's all I got for you guys. Thanks for watching. Good DS out.